Good morning, everyone. In the last class, I told you about the basic things related to the resource allocation, such as we discussed what is a resource allocation problem, what are the different type of leases, and which lease is used in which place, right? And which lease is having highest priority, which lease is having lowest priority. We have compared the leases in terms of a cost model in order to know that which lease is costly, which lease is less costly, which one is expensive, which one is cheaper, right? Also, we have discussed what is the probability of accepting a particular lease. These things we discussed in the last class. And I also told you that the various cloud service provider is providing the services in the form of leases. Like in this slide, you can see in the first column, I have listed various cloud tools or the cloud service providers. Second is their allocation policy. Like if you see about the Amazon EC2, Amazon EC2 is providing the services in the best effort mode. In the best effort mode, you know that there is no start time, specific start time, and there is no specific end time. Rather than you have to specify what is your execution time. For your time in execution time is 2 hours, then 2 hours will be provided. But at what time, that is not clear, that is not defined in the best effort mode. And if you go for Nimbus and Eucalyptus, they are doing the allocation using the immediate policy. And immediate policy stated that once the lease is reached to a particular cloud service provider, then you are bound to start the lease at that particular amount of time. At that particular time, you have to start. Okay, so there is a immediate leases are more costly, but probability of acceptance of immediate lease is very low because the time in which you are reaching to a particular cloud service provider, it may happen that all the resources are occupied. Like we discussed a 4-node cluster, in that 4-node cluster, we discussed how the processing is going on. Right? Similarly, if you go for Hygia supports 3 different type of leases. So their resource allocation is more challenging because if you are allowing the customer application in various nodes, then there is a competition. Customer is also having competition. That customer will say that no, this lease is less probable to accept, so I will submit in this mode. But the organization or firms, those who are suffering from the budget, right? They have budget constraint. So what they will do? They are forced to apply the things using the best effort, right? So such a request if will come ARB and immediate, then it is a challenging for the cloud service provider to give who highest priority or how to efficiently manage the resources is a very difficult task, right? So by keeping these fundamental things, whatever we discussed, I'll tell you 3 different resource allocation algorithms so the idea is more clear. So in order to discuss these 3 algorithms, let me tell you what is the problem. The problem is here we consider each lease in terms of a 6 tuple. 6 entities are there. Okay, each lease, if a lease is leased to a particular cloud service provider or a lease is going to be submitted to customer, then you have to follow this 6 tuple. What are the things? First one is called as ID. Okay, that is called as lease ID. Lease ID may be 1, 2, 3, 4, 5, or you can give a specific name. Like your roll numbers are having a specific meaning. First 2 may be represent the year. Next 3 digits something is representing a department. Next 2 digits may be the course name, something like that. You can manage, or you can follow the simple 1, 2, 3 order. That is the first thing. Second is arrival time. Arrival time, the time in which you have your request is reached to the cloud service provider. In order to make the competition among various customers, we'll see who arrived first. That you have to maintain. Next, you have to specify what is your start time and what time you require your leads. Okay, or you require the resource in the form of leads that you have to specify. Fourth one is your deadline. Before what time you need to provide you the service. That also you need to define. Next is called as your period. Period is in the duration. What is the duration of the service? You must specify the start time may be 10, deadline may be p.m., start time is 10 a.m., deadline is 5 p.m. Within this 10 a.m. to 5 p.m., you may require 1 hour or 2 hours. The 2 hour is called as. Then you have to specify number of nodes you require. Somebody may require 4 nodes, somebody may require 2 nodes, somebody may require 1 node. That you have to specify, right? So if you see this six tuple, okay, this six tuple, if you see the first two parameter, if you see ID and ID, so this will be decided by your cloud service provider, right? Cloud service provider, once it will receive a particular lease, it is going to assign ID and it will note down the arrival time. So this is automatic process. Nobody, no person is there to maintain everything, right? This is automatic process. Once the lease is arrived, one ID and arrival time is specified. And rest four parameter is the requirement of a particular user. Like start time, at what time you need to start, deadline, period, and number of nodes, the user need to specify. The total 6 parameters we are maintaining with respect to each and every individual lease. Right? On the other hand, if you see on the other hand, we have m number of resources. What is the resources? M number of resources means m is nothing but the number of nodes. Like last class, we discussed everything with respect to a 4-node cluster or a 5-node cluster. Okay. So let you have n number of cluster. Okay, sorry, n node cluster, not n number, n node cluster, which we can represent as n1, n2, n3 up to nm, where m indicates your number of resources. And assume that you have received n number of leases from n different customers. If you assume that one customer is giving one lease, right? Submitting one lease, so assume that you have n number of leads. That lease is called as your L1, L2, L3 up to Ln. Okay, total number of leads is n, total number of resources n. What you have to do? These n leases, based upon their tuple, okay, tuple representation, you are going to assign these leases to the resources. That is the called as the resource allocation problem. Okay, the problem of resource allocation is to map these leases onto the available nodes. Thus that lease rejection is minimized. The number of people submitted the lease, most of the people's work need to be fulfilled. So that depends upon the resource management. How you are managing the resources, how you are allocating the resources. So you have to see that how you can accommodate as number of customers. For example, one resource allocation is accommodating 5 customers. You are accommodating 6 customers. Obviously, your resource allocation strategy is better than the previous one. Right? So you have to see that part. So based upon this thing, I'll tell you a small example. Then we'll start the algorithm. See here. Here the tuple representation is given. You are given with 7 number of leases, right? With their arrival time, start time, deadline, period, and the number of nodes. For example, you can see user 1 has submitted lease number 1. Okay. And the lease arrived to the system at 8:30, but it need to start at 9, will continue up to 10:30. Okay, the deadline is 10:30. So between this 9 to 10:30, you require 40-minute slot. Okay, you require a 40-minute slot. In between 9 to 10:30, not 8:30 to 10:30. Okay, and number of nodes you require is 1. Similarly, if you go for lease number 2 arrived to the system at 8:35. It also requires 30-minute period and 3 node resources in between 9 to 10:30. Right? So So you have to check your system's availability or nodes availability. Based upon that, you can accept a lease or you can reject a lease. Okay. So these leases are required to be scheduled with a 4 available node. In that there is a 4 available node, but I will tell you with different examples so that the idea will be more clear. Each lease will be assigned to one or more nodes in any order. As you have 4 nodes, let's say 1, 2, 3, 4. Somebody required 2 nodes. Somebody required number of nodes requirement is 2, just like L3. What you can do? You can assign 1, 2, right? One may assign 2, 3, one may assign 3, 4, one may assign 1 and 4. Or whatever the possible number of combinations is coming, you can assign, right? Like L3 case we are talking, L3 require 2 nodes, so any order you can assign. You cannot say that this should be the consecutive order. There is no significance of consecutive order because they are nothing but a cluster. Whether you are assigning 1 or 2 node or 2 or 3 node or 1 with nth node or n minus 1 node by fifth node or something like that, there is no problem, right? That's why you can assign the list 1 2 or 1 3 or 1 4 or 2 3 or 2 4 or 3 4 or 4 1, whatever order is coming. Okay, 4 1 is there, n1 n4 is same as n4 n1. So where the order of the nodes is immaterial. We need 2 resources. We are not specifying which node you are going to assign to that customer in order to execute its work. Okay. So let us see what we can do. So there is a popular resource manager, as I mentioned also, that is called as your. So this is, if you see, a very open source manager. You can download and install in your system also. A set of leases to Hygia. Then how Hygia is responding? That we are going to see. Okay, the very resource allocation problem is your Hygia resource manager problem, right? It has its own. If you give the lease, already the code is there. You check how it is working. Right? As an assignment, you try to download Hygia and you run their existing algorithm, right? And their leases. You go to the lease file. You can find these lease files are nothing but the XML files. Okay, where the start time, arrival time, number of nodes, period, everything is mentioned. Okay, so see how Hygia is going to assign the leases to the resources. So whenever a new deadline sensitive lease is submitted to Hygia, the existing algorithm in Hygia to handle these deadline sensitive leases, in fact these leases are called deadline sensitive leases, is a specific deadline is there, tries to find a single time slot to satisfy the whole lease. So you can see here in the previous slide we have seen L1 is assigned. L1 is a new list. It is assigned to Hygia. What Hygia is going to do? It is going to find a single slot in between 9 a.m. to 10:30. Okay, single time slot. That is a 40-minute slot. That is a 40-minute slot and one node resource and a single slot. Single slot means it may be 9 to 9:40. It may be 9:40 to let's say 10:20, or it may be 9:50 to 10:30. Whatever, wherever you assign from 9 to 10:30, but this should be a 40-minute single slot. Okay, is it okay? You have to find a single slot as per the existing algorithm of Hygia. You can modify that algorithm as well. Okay. Now you see the second one. If it is not possible, because many cases it is not possible to give a single time slot. If single time slot is not available, or you cannot accommodate a lease with single time slot, what you are going to do in Hygia's existing algorithm? As per Hygia's existing algorithm, what is the output? Now, if it is not able to find such a slot, accommodate deadline sensitive leases to make space for new lease, right? Initially, there is no lease in the, there is no issue, but L2, L3 is already there in the system, okay? And coming, and for L4, we are in a single time slot. If you are not time slot when L4 is coming, so while L4 is coming, what happened? L1, L2, L3. What we are going to do? We are schedule L2, L2, L3 in order to accommodate L4. Okay, that's why I'm saying if it is not able to find such a slot, they will reschedule already deadline sensitive leads to make space for delivery. But after that, right, then you will not find a proper schedule, right? Or you are not able to accommodate L4, right? And while you are rescheduling, what strategy you have to, while you are doing rescheduling, it just sorts the deadline leases based upon the slack value and reschedule them considering prevention. L4 is coming, where L1, L2, L3 is already there in the system. What we are doing? We are going to reschedule L1, L2, L3 in order to accommodate L4. Okay, in order to accommodate L4, you are going to reschedule L1, L2, L3, right? But in what way you are going to reschedule them? Based upon the slack value, how you will calculate? Slack value is nothing but deadline minus divided by period. For example, if you calculate the slack time of L1 is nothing but 10:30 minus 9 divided by your 40. Okay. So 10:30 minus 9 means it is a 90-minute slot, right? 9 to 10 is 1 hour and 30 minutes. Extra 30 minutes is there from 10 to 10:30. 30 minutes is there, here 1 hour is there. So total is your 90 minutes. 90 divided by 40, whatever the value you are getting, that is the slack value of L1. So for L2, you can calculate 90 divided by 30. For L3, you can calculate 100 divided by 1040 minus 9 is your 100 divided by 30. Okay. Once you find this deadline sensitive leases based on the slack value and reschedule them considering the prevention. We are assuming that they are printed and we will sort them in the slacks value order and we are going to assign, and after that we can accommodate the L4. Okay, we are able to accommodate L4, then that is fine. Okay, but what happens if L is not correct? Then this rescheduling is cancelled. You are not going to accept that risk. No more valid. And you that operating L4 and satisfying L1 to L3. You cannot say that L2 I will print, L4 I will accept. Because you have already committed to L1 and L3, right? This strategy, if you see, one of the possible enhancement is that is you can go for several times. Like somebody is asking you 40 minutes here, right? But 410 or you can say 130 minute, 130 minute and 110-minute slot is possible. Okay, that way existing algorithm of IGR. So these time slots should satisfy the complete list within its deadline. Then it is okay looking for several time slot instead of a single time slot. As an example here it is mentioned. Schedule. Now assume that we cannot find a 2-hour slot. What we can do here? we are going hour slot. There are two slots, but each slot is 1 hour. And together they are satisfied within the deadline. Okay. So what you do in this case? Go for several time slot without putting restriction on a single time slot. Okay. You have to ensure that there should not be any intersection. Intersection should be fine. They should not interacting each other, intersecting each other. Right? For example, you can say 9 to 9:20 and 9:10 to 9:30. It is not allowed. 9 to 9:20, 9:10 to 9:30. It is not allowed because 9:10 to 9:20 is overlapping within these two time slots. So that is restriction we are going to put. Now, if a single slot or multiple slot cannot be found, it may happen. Even if you are going for single slot or multiple slot, it is not possible to accommodate that list. So what we are going to do? So if it is not found to accommodate the new list, then there is a need to check where we can make space for by rescheduling already accommodated deadline sensitive list or not. Initial is very clear. You put single time slot, the existing algorithm says single time slot. If not, rescheduling. How you are going to rescheduling? By using the slack value and the algorithm over. If you go for advancement, you go for single slot. If not, go for multiple slot. If not, go for rescheduling. How you are going to rescheduling? In slack value. Okay. Here what we are doing, there is a need to check whether we can make the space for these by rescheduling already accommodated release, deadline sensitive release or not. You can reschedule the existing lease, whether it is possible for you to accommodate the new lease or not. That you have to check. Okay. But while you are resolving this case, in the case of whenever the new lease is arrived to the system, you have to keep two things in your mind. First one, which lease should be rescheduled to make space for new lease. For example, in an existing system, you have 1,000 leads. 1,000 leads you have accommodated, and one lease is coming. One new lease is coming. For this one lease, you should not reschedule 1,000 leases. It is more costly, or it will make the system more complex. Right? You have to ensure that you ensure that this 1,000 leases, all the leases should not be suffered in order to accommodate a single lease. First question, which lease should be rescheduled to make space for new lease? That is important. You have to apply some strategy to choose which one you have to pick. I'll tell you what are the methods. Second question says that how these leases should be rescheduled. In what order you are going to reschedule. For example, in this case, you take the slack value which is used in the existing algorithm of IGR. Okay. If the slack value once you are finding, you sort them according to the slack value and you try to assign. If after assigning you are able to accommodate the new list, then that is fine. Otherwise, you have to cancel this reschedule. So these two questions you have to keep in your mind whenever you want to apply the reschedule. Which leads you need to schedule and in what way you are going to reschedule. That two things you have to address. Right? See here, the second algorithm, if you see how you are calculating the slack value is nothing but deadline minus by duration. I told you deadline is 10:20, 10:30, right? Here I told you as an example, the deadline is 10:30. Okay, and let's say the start 9 o'clock, and let's say the duration is 40. What you can say here? So this 10:30 minus 9 will result in 90. If you convert in the minute, divided by your 40. So this is your slack value. 2 point something right? So once you find the slack value, you have to check whether the slack value is less than equal to 1.1 or not. Let us see on a case. For example, my duration is let's say 9. In between 10:30 to 9 or 9 to 10:30, I need a 90 minutes. So this difference is 90 and your duration is also 90. Divided by 90 is how much? Your 1. So here if you see the slack value is 1, which is less than equal to 1.1. If such a scenario happens, you have to print a message. Please submit this lease as AR. Because AR or immediate mode only you can accommodate in the deadline sensitive mode. Okay. And also user to extend the deadline. This is a kind of negotiation. But if user is not doing that, then what you can do? You have to reject this list because you cannot accommodate. It is asking 90 minutes and giving you the grace period of 90, right? And if slack value is greater than 1.1, in this case, in the first case, I told you this is 2 point something. What you have to do? You have to find a single time slot which satisfy the complete list within the deadline. Within 9 to 10:30, you have to find a single time slot in order to accommodate that list. But if the list is not schedulable, if it is not schedulable using the single time slot, then what you have to do? You have to find multiple slots which can together satisfy your complete deadline sensitive list within the deadline. Just like 2 hour means time slot, 1 hour each, or 1 hour 30 minutes plus 30 minutes, 2 slot in order to accommodate it. Okay, but if it is still not schedulable using the single time slot as well as your multiple time slot, then what you have to do? You have to call a procedure, like a algorithm consists of several procedure. Okay, what you have to call the procedure name is find leases to be rescheduled. You find what are the leases you need to be rescheduled in order to accommodate the new leads. Okay, the procedure and the new lease is a parameter to this particular procedure, and this procedure is going to solve your problem. After that, what you have to do? You have to append the new lease to the lease set. If it is satisfied, then what you can do? You have to append it into lease set. Okay. After appending this lease set, you can call. If it is successful, you can call deadline sensitive lease, and this set, okay, pass through this particular procedure, so that this procedure is going to reschedule everything by accommodating the need. If such a is also not, you have to finally reject the new lease, because these cannot be accommodated using single time slot, multiple time slot. By calling these two procedures, first procedure is leases to be rescheduled, second procedure is reschedule leases. After doing these 4 operations, if it is not possible, then you can say no, our resource is not sufficient, so we cannot accommodate your needs. Now, take an example. L2, L3, L4 up to a number of leases. Let's say assume that there are 7 leases are there, right? Their arrival time, start time, deadline, number of nodes are given, right? If you go for Hygia existing algorithm, what you have to do? Existing algorithm says first one, you have to find a single time slot. If you go for single time slot, if it is saying 9 to 10:30, I need 40 minutes slot. So I have given here 9 to 9:40, right? The 40 minutes slot it require out of 9 in between 9 to 10:30. Assign a 40-minute slot, and it is a one node. It is asking one node, so I am giving one node here, right? Till now, I have not calculated the slack value. Okay, in the initial of the algorithm, initial phase of the algorithm. Next, L2 is coming. L2 is asking 9 to 10:30 for 30 minutes. So I am giving 3 node for 30 minutes to L2. That is 9 to 9:30. My resource is available. So I am assigning L2 here in 30. Okay, 30 minutes slot, and it is a 3 node slot. Right. Next is 9 to 10:40. L3 require 9 to 10:40. It require 30 minutes 2 node slot. Okay. So it is from 9 to 9:30. So I'm starting at 9:30 and I'm continuing up to 10, and it required 2 nodes. So I'm giving 2 node here. So L3 is accommodated. Now come to L4. L4 is asking 9 to 10:30, 4 node. 9 to 10:30. 10:30 is here. So 9 to 4 node, okay, and 40 minutes. So once you are accommodating all the L1, L3, they are accommodated up to 10. So 4 node slot is not available up to 10. What you can do, 10, but if 10, as it is a 40-minute slot, it will go up to 10:40. 40. Up to 10:40, you are violating the deadline of 10:30. So L4 you are not going to assign in the normal mode. Like time slot. If it is not satisfiable by the single time slot, then what you have to do? You have to go for rescheduling. In the very first algorithm I told you, you have to go for rescheduling. What you can do? You have to calculate the slack value of already assigned leases. What are the leases already assigned? L1, L2, L3 is already assigned. Is L1, L2, L3, I have to calculate the slack value of these 3 leases. So leases is nothing but 10:30 minus 9 divided by 40 is equal to 2.25. For 10:30 minus 9 divided by 30, that is 3. For L3 it is 10:40 minus 9 divided by 30, you are getting 3.33. And you are sorting L1, L2, L3 based on whatever value you got. It is slack value. So if then you are getting the same order. Getting same L1, L2, L3 order. So we are going to assign as per the slack value. There is no change. There is absolutely right. What you have to do? First algorithm, even second algorithm, that is your DPS algorithm. I'll tell you in the next slide onwards. Okay, DPS suggests that multiple time slot. Multiple time slot is also not possible because up to 10, 4 node is not possible. After 10 only I can provide you 4 node slot. So if you go for multiple time slot also, before 10:30 it is not possible. If it is asking 9:40, it is asking the 4 node, it is not practically possible. In the second, what you have next, you have to perform that two, you have to call that two procedure in the case of DPS algorithm and solve this problem. But in after finding this the value, you sort them, you simply reject it. So L4 is place. Now in L, the time is 10 to 11. So 10 to 11 is the time. It requires 10 1. I am giving 10 minutes 1 node slot here. Before 10 1 node slot is available, but what it is specified? It is specified the start time is 10. So I can keep before 10. Exclusive 6, 10 to 10:50, 10 to minute slot, it is asking 30 minutes. So it is starting from 10 and it is going to 10:30. And L7 is 3 minute slot in between 10:30 to 11. So 10:30 to 10:50 I can accommodate L7. So leases you can see here we have accepted only 6 leases. Only 6 leases. In the first algorithm, that is your Hygiea algorithm, base algorithm, right? Then, so this is the future of us sorts the leases based upon the slack value. Accordingly, it makes the leases schedule as L1, L2, L3, as in the earlier case. But in this case, also it fails to accommodate L4, hence it is rejecting it. So if you go for DPS algorithm, DPS will try to reschedule the already accommodated leads by finding multiple time slot. However, it is unable to accommodate L4 as there is no multiple slots are available. Thus, it is rejected. But how it is doing this rescheduling? It is doing the rescheduling based upon the decreasing order of the number of nodes. Right? L4 is coming. You are going to reschedule. You are going to reschedule L1, L2, L3. Right? So what you have to see in the DPS algorithm, the second algorithm, you have to check the number of nodes. The number of nodes is 132. Right? If you sort these leases according to their increasing order, okay, there is none decreasing order, then L2 will come first, L3 is second, L1 is third. So even if you assign in this order L2, L3, L1 instead of this the previous order L2, L3, you are not going to accommodate L4 as for this particular data, right? So DPS algorithm also failed. The leases in the order of L2, L3, L1, if you go for the number of nodes and they are decreasing order, but still fails to accommodate L4. Therefore, what it is doing, it roll back the rescheduling and reject the L4. You will not accept the rescheduling part. Then rescheduling is accepted. Otherwise, you have to roll back it. Okay. So this is for the first two algorithm. So let us see the first procedure that is followed in the DPS algorithm. That is the procedure 1, procedure 2 we will discuss. Then the DPS algorithm will complete. So I told you, whenever you are calling the procedure find leases to be rescheduled and you are sending one parameter, that parameter is called as your new lead. New lead means in our example case it is L4 where L1, L2, L3 is there in the system. I am sending L4 to this particular procedure in order to find the leases to be rescheduled. See here, this is accepted here. Once this procedure captured this L4, we have sent L4. So L4 is now assigned to your S. S is a variable. Then what we are doing here? While true, it is always true. Infinite loop you can say, but it will not be infinite, right? Because SP, we are going start period and this is called your end period. What is start period is saying? Start period is taking a function which is a maximum. Determine what is current system time. For example, the current system time is let's say 11. Okay. And what is saying? Minimum start time of all leases is S. For example, these 4 start time is let's say 11:30. So sometimes leases will be there. That type of all leases that are there in S. Okay. So if multiple is there, you take out of these two, you take the maximum one. The maximum 11:30. Because before 11:30, you cannot start the new leases, right? That's why we are defining the start period of that lease is the maximum of two things. One is current system time, another is minimum start time of all the leases in S. Coming to the end period, how we are defining the end period? End period is nothing but deadline DI of all the leases in S. Whatever leases are there as a new lease in the set S, what you are doing, you have to determine the deadline of all the leases. Let's say the deadline of this lease is, let's say 12. Sorry. So if it is 12, what you can do, if multiple leases are there, out of case you find the maximum deadline, whatever the maximum end period. So here our single lease is there. So it is the start period is 11:30, end period is 12. Then we are forming two different lease sets. Okay, one lease set, that is the lease set, is equal to all the leases in set S. We are preparing by defining the leases that are not in S. Not in S means what you can say? Not in S means your L1, L2, L3. Total 4 leases are there in the system now. L1, L2, 3 already accommodated. So all the leases not in set S. So it is not there in L4, but L1, L2, 3, L3 is there in the system. But it is giving some other conditions also. Having their scheduled time inside this SP. So this one is saying L1, L2, L3, right? You take L1, L2, L3. Out L1, L2, L3, you have to see the schedule of L1, L3. If it is collide SP and EP, that is 11:30 to 12:30, sorry 12, then you have to put in the lease set 1. Otherwise not. So it may L2 maybe L2, L3 maybe collide, but L1 is not available. You have to prepare another lease set, that is lease set. What you are doing? All the leases not in set S. Again L1, L2, L3 not in set S means having schedule time. Means less than 12. Okay. And end time. End. If such a case will be there, you put all the leases in the lease set. You have to check L1, L2, L3 because they are also requiring request. They are also asking the resources in a period of time. So it may happen that out of that period, we are assigning one small period, like 9 to 10:30, it is asking 20 minutes. Where is that 20? So that's why the repeat end time is greater than less. If lease 1 set, lease 2 set is empty, then what? Break this procedure. You have to break this procedure. Okay? Then dot add this set. So you have to append the lease set 1 with this, and you have to also append lease set S with the lease set 2 with the S. Then only this procedure will be completed. Up to the second procedure. Okay. You can see call reschedule deadline leases. Leases that contain your new lease as well. That's why it is written here. Append new lease to leases. So if you call this procedure, leases swap is equal to call find order of the leases by swapping. So it is calling another process which applies the process of swapping. That you are giving to this procedure. This procedure apply the process of swapping. Means there is two different sets are there. So in between you are performing the swapping. And if it is not possible, you schedule without considering backfilling. After finding this order the leases by swapping, then you have to apply the using swapping without considering the backfilling. Backfilling come in another procedure. Using procedure which is in turn depends upon this particular procedure, then what you have to do? You have to schedule this procedure using backfilling. Lease is not ready, then you can assign other leases. Okay, even if it is in the order 1, but you can assign other leases to the fit into the system. If doing this swapping and backfilling, the procedure is not complete, then what you have to do? So, because backfilling is not implemented in this algorithm, because backfilling takes more time and backfilling makes the algorithm too complex. So, what? Sort the lease set in increasing order of their deadline. So, whatever lease set you have which was found in the procedure, that you have to sort using in the increasing order of the deadline. So consider the leases up to the new lease from the lease set, sort up to new lease in the decreasing order of the requested. Okay, you have to go through the deadline, it is okay, but at the same time also you have to do decreasing order of the requested resources. That means the lease which require more resources that will come into. For example, 2-3 leases may have the same deadline. So, yes, you have to see what is the number of nodes of each and every individual lease. The lease with maximum number of nodes will be accommodated first. Okay. They have taken the lease set up to new lease, again the same set, and it is comparing the first one with second one. They want to swap. For example, in a particular set, let's say here 1, 2, 3 is there. Another set also 1, 2, 3 is there. What it is doing? It is swapping 1 with 1. Obviously, it will not do any changes. 1 with 2, 1 with 3. So it is swapping 1 and 3, and it is seeing that whether we can accommodate the new lease or not. Okay. So if requested resources of the lease are less than that of the new lease, then only if after swapping the lease and next lease can be completed within their respective deadline, then the requested resources can be allocated. So this is the condition you have to fulfill. Whatever requested resources of a lease should be less than the next lease. Then only you can perform the swapping. Okay. After that, what you have to do? You have to, if it is satisfying, then you have to swap the lease. And next lease, maintain the scheduling information while deciding the order of the leases in above described bubble sum. So it may happen that after accommodating 4, maybe the order is coming like this 1, 4, 3, 2. It may come, right? That order will be followed in order to accommodate the 4th lease in the IJ resource manager or in the DPS algorithm.